All right, here we go on some of these problem sets for using the chain rule. I'm going to write down what the chain rule is again. If you've got a function that is composed of one function inside the next, for example, f of g of x, then h prime of x goes like this. It's the derivative of the inside function, g prime of x, times the derivative of the outside, leaving the inside alone, f prime of g of x. And this is a rule for composed functions. A composition is what we kind of learned in Algebra 2. And it's a new rule for us when taking derivatives. I'm going to pick a couple of examples here just to kind of illustrate that. I'm going to do on this first page, number 5. Suppose that f of 2 equals 3, f prime of 2 is 4, g of 3 is 6, and g prime of 3 equals negative 5. Those are all pieces of information that will come secondarily. We want to find h prime of 2. Now, it's very tempting to put a 2 in there immediately, but first off, h of x, it looks like, is a composition of functions. I'm just going to rewrite it here just to make the lines nice and tidy. So if I want to find the derivative h prime of x, I use the chain rule. It's the derivative of the inside, f prime of x, times g prime of f of x. Now that's just the general rule. That's the chain rule for anything. Now I'm okay to say, so h prime of 2, and I put in, wherever there's an x, I just put in a 2. I need to find f prime of 2, and I need to find g prime of f of 2. Now I use, for f prime of 2, that is up here. Oh, that's 4. I'll fill that in. So that means that is 4. And then I need g prime of what is f of 2. So I go back up to the top, and it says, oh, f of 2 is 3. So I really need g prime of 3. See how I'm working from inside out? One more step. It's 4 times g prime of 3 is negative 5. 4 times negative 5, negative 20. So take the derivative first, express it in terms of the chain rule, and then use the information to get your final answer. All right, we should do, oh yes, one like number 6. Given the graph of f of x, evaluate. All right, so this really should say d dx, the derivative of f of x squared, and that x equals 1 means at x equals 1. So I'm going to put at x equals 1. So it really is find the derivative of this function and then at x equals 1. So it here says another way to think about this problem is let g of x be f of x squared and then find g prime of 1. Okay, yeah, that notation is a little bit clunky here, but we do need to find the derivative of a composed function, f of x squared. Now you could just say, write it out, that's f of x times f of x, and use the product rule. That's okay too. We will get the same thing. Since we're here for the chain rule, I'm going to find the derivative of this composed piece. So g prime of x, using the chain rule, is the derivative of the inside, which is f prime of x, then times the derivative of the outside. That's a squaring function. So I'd use the power rule, 2 times f of x to the first. So now I've got my derivative. Now g prime of 1 goes like this. I just put in a 1 wherever I see an x. So it's f prime of 1 times 2 times f of 1. Now, there's no table here, there's no list of values, but there is a graph. Oh my goodness. So here's how you do that. Let's do this easiest one first. 2 times f of 1, that means this is the f function. And so what is f of 1? My eyes go to where 1 is, and I go up to see what that dot is, and it looks like these increments are, every big square is 2, so that's 1 comma 3. So f of 1 is 3, so we're looking at 2 times 3. Now this part, f prime of 1, we need to think of the derivative sometimes as the slope of a tangent line, and this is the slope of the tangent line at 1. So my eyes go up to around that 0.13, and I just make a little slope line. This one is a straight line, so you just need to kind of find out, okay, what is a point that I can get that is a nice and easy slope of rise over run from 1,3 to 2 comma 2. That I go over 1 and go down 1. That slope is negative 1. So that's f prime of 1. I'm looking at an answer of negative 6. All right. You are welcome to pause and kind of internalize this or try out the next one. Or I'm going to keep going to another one that I think is a pretty good illustration of a different way to do chain rule. Number 18. F of x is 4x plus 5 times sine of x to the 4th. I'm going to rewrite this as 4x plus 5 sine of x to the 4th. Those are equivalent. And now f prime of x, I can move from left to right. The derivative of 4x is just 4. And now the derivative of 5 times some function is going to be, I'm going to preserve that 5, because if you take the, the derivative of k times any function means k can be taken out and you still preserve, and that scalar multiple is preserved. So I'm going to take the 5 out and then find the derivative of sine x to the 4th. I use the chain rule for it, so I'm going to put a big bracket around here, and I'm going to take, let's see, derivative of the inside, which is cosine x, times the derivative of the outside, and that's a power rule, 4 sine x to the 3rd. We'll clean that up. Derivative of f prime of x is 4 plus, let's see, 5 times, this is still, I'm going to put the 4 in front, 4 cosine x sine cubed of x. We could keep it like that, or you could say 4 plus 20 cosine x sine cubed x. Whew! Chain rule. Okay, another one that I think you should maybe see. This 51, I'll give you a hint on this. This part here, d squared y over dy squared, that means find the second derivative, which just means find the first, clean it up, and then find the second, find it again, the derivative of the derivative. And I'll make a separate video for this one, but as a hint, that is going to be treated as, what I just underlined there is a product, and at the same time, when you split up that product, it's going to be a chain inside as well. Product and chain 2. And then this one is a chain, or you could call it a power. And as another hint, you will use, something to make it easier, a double angle formula to make number 51 a little bit easier. Okay, we are almost there. There's one more thing you need from me when it comes to derivatives of e to some power. Let's go down here and let's make a little separate page and take a look at e to the x. Where are we? Okay. You don't have to remember this, but this is what the y equals e to the x looked like. It's an exponential function. It has an x in the exponent. And e to the x was that special transcendental number that was 2.71828. That's not as important as just an exponential function. An exponential function always went through the parent function, the point 0, 1, and it behaved, if the base was positive, something like this. That was the line y equals e to the x. Now, if we go back to find the derivative of that, which is what we do in calculus, we find slopes of tangent lines. So I'm going to start from the way back at negative infinity and just make slopes of tangent lines at tiny pieces and make all the way up so that I have an idea of how the derivative behaves, and then I'm going to map it right down below. It's always good to see if there's any spot where the derivative is 0. There doesn't happen to be a place in e to the x. And out on the left, slopes are very small but positive. And then as I get closer to the y-axis, the slopes tend to curve up a little bit. Right about at the point 0, 1, it looks to be a slope of 1. And then those slopes start to get steeper and steeper until they become quite steep as we go off to infinity. That's funny. The graph of the e to the x looks to be, of the derivative, looks to be exactly like what it was before. And that is our next derivative to have in our tool belts. The derivative of e to the x is e to the x. The derivative maps back on itself. But now that we're doing chain rule, I will have a revised derivative to look like this. The derivative of e to the u, because we aren't just going to have one function anymore. Sometimes that u, that power, might be another function, so we have to think of it as a chain rule, which has an inside and outside. So the derivative of e to the u is still e to the u, but then we take du dx, because this is now with respect to the chain rule. That is what we might have to do. We might have composed functions. So that's a new derivative to put into your tool belt to have ready, is the derivative of e to the x, or derivative of e to the u. So on these last problems, on this one that says page 202, number 15, this is e to the 7x. And we're going to take the derivative of that. I'm going to go back to like basic pieces and say what is the inside function, what's the outside function. We are on the very inside. The first thing you do with x is you multiply it by 7. So that's inside, which is like a 7x. And then the outside function is e to the x, or e to the u, we'll call it. So y prime is, by the chain rule, and I'm going to keep it stop at one step at a time here. I'm going to take the derivative of the inside, so d dx of 7x, times the derivative of the outside, leaving the inside all alone. But the derivative of e to anything is just e to that anything. That comes back to itself. I'll clean it up for step 2. The derivative of 7x, oh, whew, thank you, that's just 7. E to the 7x is our derivative. How about one more? Let's do this number 17. This is x cubed times e to the x. As I see that, oh man, that's a product. X cubed and e to the x. So I'm just going to put, let's see, product rule is the derivative of the first times the second. So I'm just going to put d dx of x cubed. I'll clean that up later. Times the second, e to the x, plus the first, x cubed, times the derivative of the second. So I'm going to take the derivative of e to the x. That's what I would recommend, especially as we get to these more sophisticated functions, is just take it one step at a time and delay taking derivatives of everything all at once. So delay them a little. Now the derivative of x cubed, that's 3x squared, e to the x, plus x cubed, and the derivative of e to the x is just e to the x cubed, e to the x. You could clean this up a little bit. It's not necessary, so I'm going to box my answer here, but I could also take out an x squared, and I could also take out an e to the x at the same time and factor that and make that 3 plus x. Okay, man, are there any other things that you need to know? There is not. I think you have everything you need. And so some of them are a little tougher than others. Wow, as I'm looking at that one, that's going to be fun. A quotient and chain at the same time. Hey, do what you can. Thank you so much for your interest and attention and your work in calculus. And we'll yak at you later.